Hi all, good afternoon. I belong from Group 6. Here we are here to present a semester project. The title of the project is Optimal Maintenance Scheduling of Multiple Infrastructure Networks. And these are my group members: Anjani, Ayatune, Cyril, Manikanta, Malati, Navya, Pranit, Sachin, and Someshwar Reddy. And this, we designed the group project introduction first. The agendas of our group project are clearly discussed here. First, we decided the object of our project, then the literature reviews. We go through the that were previously done by some other students and the lecture professors and get some information from that. And and next we went to the methodology and how to complete the project by using different algorithms. We have so many algorithms in our market. So we use the evolutionary algorithm for this project. And then we took a case study and we took the road section and that is considered and examined, and the section is examined with respect to our project objectives. And then findings. The findings are clearly mentioned in the project report by using Excel sheets, by using the solver, and the conclusion was made. The references are also being attached in the PPT in the report. And now my group mates are going to discuss in detail about the project. I'm giving you next to Anjani.
This project is about a comprehensive work on analyzing and evaluating effective approaches for restoration of utility cuts. An infrastructure deterioration process undergoes stochasticity because of variances in material properties and how they behave. So, identifying and quantifying them is not so feasible enough. So, scheduling maintenance activities requires optimization strategies to take this unpredictability. So, that is what we are doing here. The main idea or goal is to reduce the roughness index. To measure the performance of pavement, roughness index is used, which is a gauge of ride quality. So the goal is to reduce and minimize the roughness index and reduce the impact of utility cut on pavement with appropriate timing of pavement treatment with minimum cost. Uh, yeah, this is a graph which represents the pavement condition through the time. So there is reduction in performance through the time. The graph represents the sudden drop in or vertical devaluation of pavement performance after the occurrence of utility cut. So if pavement condition can be measured just before and after the occurrence of a utility cut, the performance reduction can represent the exact damage to the pavement condition due to the utility cut. So we here are to reduce uh, the impacts due to the utility cut.
Okay. Um, the objective of this study is to find the impact of the utility cuts on pavement and the severity of damage on pavement performance. And for this study, pavement performance is examined based on the International Roughness Index data with and without treatment. The RIR and the IRI, which was developed in 1982 as a part of an international experiment conducted in Brazil. It constitutes the smoothness, safety, and the ease of the driving part. It is also one metric for pavement performance and influences traffic safety. IRR is also a popular tool which is used by transportation organizations to distribute annual maintenance and rehabilitation plans for their road network. And also, for this project, the IRI evolution for the collected data is identified through a mathematical analysis versus time, while finding the optimum performance threshold to minimize average IRI and average total cost. And for this current project, yeah, the data is collected from studies of conducted pavement performance analysis using different models for pavement preservation. The road pavement section is considered in this study as it is located above underground utilities such as water or sewer pipelines, and then hence the pavement needs to be cut to facilitate the maintenance of the utilities from time to time. So this data is related to the physical attributes such as construction cost, treatment types, and environmental attributes such as traffic load and weather conditions on the pavement.
Yeah. For the payment roughness, payment performance values are measured in the form of International Roughness Index, that is IRI. And the IRI is the primary indicator for the ride quality. And the IRI determines the ease, safety, and the smoothness of the driving path. And this IRI is a crucial indicator for driving safety, and it's dependent on the pavement distress, which are present on the pavement. And the IRI measures the surface texture of the pavement. And, we need payment management systems and the performance and modeling tools to maintain productive and economical roadwork. And the IRI is a gauge of ride quality and is one of the metric of payment performance. It influences the traffic safety, and IRI is popular too, and it's mostly used by the transportation organizations to distribute the annual maintenance and rehabilitation plan for the network. And the below table shows the IRA condition criteria. For less than or equal to 60, it will be very smooth. And for 61 to 120, it's gonna be smooth. And 121 to 120, 170, it's gonna be fair. And 171 to 220, it's gonna be rough. And greater than equal to 220, it's gonna be very tough.
Yeah, here I am here to explain about the relation between the utility cuts and the pavement condition. A utility cut can occur during different types of pavement service, and different types of treatments are typically applied at different stages of the pavement. Utility cuts are two types: short-term treatments and the long-term treatments. Short-term treatments are temporary disruptions after the cut was made. Long-term are cracks, swellings, and the consequences of the physical conditions of different types: service life, operational condition, and etc. Here, the cost and treatment. Pavement maintenance rehabilitation is in pavement management systems. It's essential to make cost-effective use of PMS and MR budget. Pavement maintenance costs are commonly based on the total annual maintenance, repair, and operation costs. Here we have a formula based on that: labor cost plus type of material plus miscellaneous. Labor cost is calculate the number of maintenance hours based on the technicians from the start to the finish of the work. Type of material, which depends on the type of material which are used in the utility cut and used on the work. Miscellaneous item, it includes all other expenses, namely suppliers, lack of men, etc. Here, the frequency of the utility cut. The more the utility cut it's made, it's going to be defect the pavement service life.
Sorry, Malati.
The main aim of the project is to find optimal performance threshold required at the time of treatment to minimize the severity of utility cut on the pavement. To do this, the data collected on road pavement session in two ways, like with treatment and without treatment, by using mathematical analysis through IRI evolution curve versus time. Coming to data collection, the studies conducted on pavement performance analysis by using different models for pavement preservation. The road pavement session considered in this session is basically on underground utilities such as water or sewer pipelines.
Optimization framework. Now I'm gonna explain about this. Right from the start, we need to identify the system performance index. Then the next step, we need to select system candidate performance threshold, which is also known as CPT. From there on, now we need to specify the system lower and upper performance limits. Then it comes to identification of the events impacts on system performance. And the next, then it goes to the access disruptive event impacts on system performance. After that, it's divides into two sections. Like one is select approximate measure of effectiveness, and the other one is estimate system treatment cost for the CPT. Now, when it comes to select approximate measure of effectiveness, we need to select, like we have three of them. One is treatment service life, the other one is average increase in performance, and area bounded by the performance curve. Coming to the estimate system treatment cost for CPT, it has three types. One is agency cost, the other one is user cost, and the last one is community cost. The estimate system treatment cost for CPT hence here, whereas the select approximate measure of the effectiveness continues and it takes to estimate system treatment cost for CPT, which has a minimum cost and a maximum benefit. There, it goes to the optimal CPT. If reached, if the optimal CPT is reached, then this process gets end, or else it's again gonna take us to the selection of the candidate performance threshold, where all the process repeats again until the optimal CPT is reached.
Yeah, I'm going to explain about our studies. In this study, payment performance is examined based on the International Roughness Index data, and this evaluation is for the collection data is identified through a mathematical analysis. For the proposed optimization framework, a road section is being considered that is to be maintained using a treatment. The road section is above underground utilities. To maintain these utilities, the payment must be cut to facilitate access. The following parameters are the considered for the optimal results. So this is a formula for the IRA pre-treatment, and the PI TPI equals to, and this formula where the TPI is a payment treatment age at the performance threshold. This is measured in years, and AAFI and AATT are the average annual freezing index. Will be in thousands, and the average annual truck traffic volume, this will be in millions. So respectively, the alpha, beta, and gamma, the coefficient to be estimated. And then the utility cut. Utility cut is all about like the IRI at utility cut with this 20% of severity. So we are going to use the 20% of service life to the IRI treatment. Because in this model, it is expected that the utility cut will take place every 5 years, the following treatment application. So reducing the payment treatments, remaining service life by 20%. And then comes to the treatment cost. It can be found by this following formula, where the cost of PI equals to sigma dot E gamma into PI, where the PI is a payment performance threshold measured in IRI, and sigma and gamma the coefficient to be estimated. And the next table is talk about the IRI values and different road attributes, and the data is collected from the data from the collector from the PDF. The SIR gave us a reference. So the next spreadsheet is going to explain Sachin.
Yeah. I'm here to explain the performance model. Can you go to previous slide, please? Yeah. Here you can see the spreadsheet, which is explaining you the data given by the where we generated by using the IRI equation to the case studies, and we generated a model graph where IRI versus time. As the IRI increases, as the time increases, IRI also increasing. You can see in the graph in the next slide. Next slide, please. Yeah. Okay, you can see the graph, which is IRI versus time. As the time increases, IRI also increases. By using the different type thresholds, we generated a treatment, and we optimizes by using the solver. We optimizes to minimize the IRI and the total cost. After optimizing in the solver, we got a values of threshold 10.100.263, and the utility the cut frequency is 5. The average IRI is 95.7, and the minimum cost is 375. So and by changing the thresholds, the values have been and changing. So we optimize it to this level. And coming to utility cut, the utility cut is done for every 3 years according to the what we got from optimization. And the utility cut is done. And the next slide, please. Yeah, by changing the threshold value, we got the number of IRI, average IRI, and average total cost. By using the data, we generate a model where it says that as a budget decreases, the IRI value increases. You can see the clearly in the graph that as the IRI is increasing, the budget is decreasing. Now, Somesh will be explaining the conclusion.
Yeah. Coming to the conclusion and summary. With the help of this study conducted on optimal maintenance scheduling of multiple infrastructure networks, we came to know how the payments get impacted or affected due to the utility cuts, and how the frequency of utility cuts are calculated, how the frequency of utility cuts are to be happened, and what's the time is desired for the utility cuts, and what are the optimization methods used to reduce overall cost, time, and frequency of the utility cuts. Current study conducted comprehensive research and evaluated effective approaches for the repairing of utility cuts. The analysis conducted in the current study will outline the merits of each strategy and suggestion improvements for the method utility companies and road agents should be used in further. The goal is to reduce the roughness index and the impact of the utility outages to be on the both transportation infrastructure and traffic in the urban areas. After conducting a data-based numerical analysis on the IRI values for a period of 17 years with a utility cut of 5 times on the pavement, study found that the reduction in an IRI with the treatment conducted on every utility cut at optimum performance threshold of 100.2635. Current study believes that it's possible to find numerous optimum performance thresholds for various IRI indices using evaluation algorithms. As of for the current data, optimum performance threshold at 100.2635 is found to be effective in reducing the indices and improving the payments. And these are the reference materials we have been used for this entire study. Thank you.